Okay, this is part one of Trigonometry Made Easy. It's a very elementary version of trigonometry. It's related to triangles, and I'll try to go through it and make it as clear as possible. I think most people should be able to pick it up very easily. First of all, let's talk about measuring angles. In measuring angles in trigonometry and with triangles, the angle is typically measured counterclockwise from baseline. If this is the baseline 0, then counterclockwise, halfway between 0 and 90 is 45 degrees. So that's just something to remember. The angles are always measured in a counterclockwise direction. If you want to measure 135 degrees, then all you have to do is measure again 135 degrees from this baseline of 0. Okay, there are several types of triangles, and as I mentioned before, we're going to focus on triangles here in this um, tutorial on trigonometry. There are triangles based on angles. The names are based on their angles. An acute triangle is where all three angles are less than 90 degrees, as shown here. An obtuse triangle is where one angle is greater than 90 degrees, right here. A right triangle is one angle being 90 degrees. So those are the types of triangles based on the angles. Now there's triangles that have names to them that are based on the sides. A scalene triangle is a triangle that has all three sides with different lengths. An isosceles triangle has at least two sides that are of equal length, and that's shown here. An equilateral triangle is all three sides of equal length. And you notice these hash marks here describe how long relatively each side is. But again, scalene is no sides equal, isosceles, two sides equal, and equilateral, all sides equal. Now, there are certain properties of triangles that we have to understand before we talk about trigonometry. All triangles have three sides, and that kind of makes sense. That's why it's called a triangle. The longest side is opposite the biggest angle. So the longest side here is opposite this angle here, which is the largest angle. The shortest side is the one opposite the smallest angle. All internal angles add up to 180 degrees. So if you measure these angles, each one of these angles internally, inside the triangle that is, they will add up to 180 degrees all the time. The sum of any two sides of a triangle is always greater than the length. So that makes sense because this is the shortest path between 2 points. And if you take any other path, like this way to this way, it's going to be longer. So the length of two sides, any two sides, is always greater than the other side. Now, there's a property of right triangles you may have heard of. It's called the Pythagorean theorem. And all it says is that if you have a right triangle, where one angle of the triangle is a right angle, or 90 degrees, then a squared plus b squared equals c squared. So that means if you want to find out what the length of c is, you can find that out by knowing what the length of A is and what the length of B is. And this is the formula. C is the square root of A squared plus B squared. And A squared obviously is just A times A, and B squared is B times B. So you can do this on a calculator rather than manually. You just take A multiplied by itself, add to it B multiplied by itself, and then take the square root of both, and you'll have the length of C. These are the triangles, and I just wanted to mention this briefly, that a right triangle can be in any orientation. When I was younger, and they first started talking to me about right triangles, I think it was in middle school, I thought that a right triangle meant it was different from a wrong triangle. I didn't understand that a right triangle meant a right angle triangle. So that's all this is meant to show. You can flip them around and still write triangles, as long as they have one 90-degree angle in them. So there's several notations when talking about triangles. First, let's talk about what they're described as. If you have an A angle here, then the side opposite that A angle is called the opposite side. The side adjacent to the A angle is called the adjacent side. And the side between A and B, or across from the C right angle, is called the hypotenuse. So sometimes you'll see a notation like this one where lowercase letters denote the angle and uppercase letters denote the sides. And still there's other representations where they use lowercase a, b, and c to represent the sides, and the Greek letters alpha, beta, and gamma to represent the angles. And that's the one we're going to use because that's usually the most common. Okay, so alpha is angle A, beta is angle B, and gamma is angle C. And again, the lowercase letters refer to the side, the length of the sides of the triangle. Okay, so now we're going to talk about some ratios. And these ratios are given funny names, but they're basically just ratios. They're called sine, cosine, and tangent. Sine of an angle, in this case I use A for alpha. Sine of alpha is the ratio of the opposite side to the hypotenuse. So the sine of this angle here, A, is simply the ratio of A over C, the opposite side over the hypotenuse. Cosine of alpha is the ratio of the adjacent side to the hypotenuse, or B over C. So this is B and this is C. So the cosine of this angle is the ratio of B over C. The tan of alpha, tangent, is the ratio of the opposite side, A, divided by B. These are really the basic three formulas you just have to memorize. If you memorize these for 90% of the practical applications you run into, you'll be fine. Okay, so let's take a practical example now. First of all, talking about the table of the ratios again, you can look up these angles in a table like this, which shows that, for example, an angle of 30 degrees has a ratio of 1/2. So that says the ratio of the sides A divided by C is 1/2, or C is twice as long as A. That's all it means. So the sine of 30 is described as 1/2. And again, it means that A over C is 1/2, or C over A is 2 to 1, or C is twice as long, the hypotenuse is twice as long as A. Okay, now we're ready for a problem. Here's a problem of a house, a chimney, and a triangle. Looking at this one here first, we want to find the length of ladder we're going to need to get to the top of the antenna to get to the top of the chimney to fix your antenna. To do that, we need to know some facts. So let's say, for example, that we measure this angle A with a protractor, and it turns out to be 50 degrees. We know the height of the chimney is 20 feet. We don't know how long the ladder needs to be. So we know A, we know alpha, and we're trying to find C. So we use the first formula that was shown on the previous slide, where the sine of alpha is A over C. So we know A is 20, we know C is unknown, and we got to figure out sine A. So we look up in a calculator or on a table, probably a calculator, the sine of 50, and we multiply it by C. Why? Because we multiply C times this side and both sides of the equation, and we have sine of 50 times C, and C cancels out on this side, so sine of 50 times C equals 20. So now we look at C would be 20 divided by sine of 50. We look up on a calculator the sine of 50, and it turns out to be 0.76. So we can say that C is 20 divided by 0.76, or 26 feet. So we need a ladder that's 26 feet long to reach the top of the chimney so we can fix the antenna. Probably ought to have it a little bit longer just to be on the safe side, but that's how we do it. By the way, angle beta is 40 degrees. Why? Because we said that the sum of the angles, internal angles of a triangle, is always 180. So we know that the gamma is 90 degrees. We said that alpha was 50, and therefore beta has got to be 40 to make the total come up to 180. Okay, here's another way we can find the same length or a different length of a ladder using the cosine and using different things that we know. In this case, we don't know A, the height of the chimney, but we know the distance between this vertex of the angle and the base of the chimney. We're saying that's 30 feet. And we said that the measured angle of alpha is 40 degrees. So again, very similarly, the cosine of alpha is B over C. We move terms around again, and we say cosine of alpha times C is B. Therefore, the cosine of 40, which is the angle, times C equals 30 feet, what we measured. So C is now 30 feet divided by the cosine of 40 of 0.64. So in this case, we need a ladder of 39 feet. And again, this angle is 50 degrees because these two are adding up to 90, and gamma is 90, so that makes 180. Okay, let's suppose we want to know the height of the chimney. And we know that B is 40 feet, the distance from where we measure the angle to the base of the triangle. And we know alpha is 50 degrees. Well, this is formula 3 we use, the tangent. Tangent of alpha is A over B. Again, we multiply both sides times B, and we get tangent of alpha times B equals A, which is the tangent of 50, which is what we said the angle was. And we measured B as being 40. So the tangent of 50 times 40 equals A. The tangent of 50 turns out to be 1.2, and multiply that times 40, and we get 48 feet. So the height of the chimney in this example is 48 feet. So if we need a wire to go from the antenna down to the ground, we need at least 48 feet. So just one other thing to remember, again, the Pythagorean theorem. There's something very common in right angle triangles. It's called the 3-4-5 triangle. That means if one side is 3, the other side is 4, the hypotenuse, or C, is always 5. And that's from this formula here. 3 squared plus 4 squared equals 5 squared. Or 9 plus 16 equals 25. So if we knew B is 40 feet, and A equals 48 feet, that's 2,304 plus 1,600 equals 3,904. If we take the square root of that, because C is the square root of A squared plus B squared, we find that C turns out to be 62.5 feet. So here's some common values you could memorize, but it's really not necessary. But it does help sometimes. The sine of 0 is 0. Cosine of 0 is always 1. The sine of 90 is always 1. The cosine of 90 is always 0. The tangent of 0 is 0. And the tangent of 45 is 1. And the tangent of 90 is infinity. So you'll become more and more familiar with these as you look up more values of sines, cosines, and tangents. So that's about it. I hope you like this video. Thanks for watching, and please like and subscribe. Thank you, and see you in the next video.